Okay, so I am recording right now our first class here, ITKM 560, and let's get to it. So today I'm going to review correlations, okay? I'm going to review correlations, and I'm going to do it both in R and in SAS. I don't want you guys to fixate on code, okay? I will share with you guys the code, the data, the video. I will share with you guys everything, okay? And I am going to do this in R, and then I'm going to do it in SAS, okay? So to start out in R, let's just figure out what a correlation is. Because I'm a little bit behind here, I am going to go on to our trusted source of Wikipedia, and I'm going to do correlation. Okay. There are better sources to understand these things in statistics. Okay. But in the end, this is actually going to give us a good idea. Okay. And what I really wanted to do to be able to start explaining correlations, okay, is really taking a look at this graph over here. Okay. So imagine for a second, okay, that you have a bunch of observations. And I'm looking at, first of all, this one over here, okay? So imagine on the x-axis, we have a variable like age. And on the y-axis, we have something like income, okay? So the question is that we're going to be asking in analytics is, does age and income have any relationship? I'm not asking if one causes the other. That's a totally different story. What I'm asking is, are age and income related? And we can get something, if we plot all those data points, if we ask a bunch of people on the street, hey, what's your age and how much do you make? Okay, we're gonna get observations. And it can plot out like this one that says 0.8, like this one 0.4, like this 0, like this negative 0.4. I'm guessing this is negative 0.8. I can't see it. And here's this negative 1 all the way over here. Okay. And I'm just looking at this top row. The numbers that you see on top, these are the correlation coefficient. Okay? And this gives us a little bit of a description. So somebody is not muted. Oh, we have a new participant. That's fine. So Juan, welcome. We can talk a little bit later.
Okay.
We're just starting out talking about correlations. Okay?
Okay.
If you don't mind, if you can try, I'm just going to mute you. So if you have any questions, unmute yourself and please do interrupt as you have a question. Okay. Better for the sound. Okay. So a correlation of 1 means that there is a 1-to-1 relationship between age and income, if that were our two variables. That means as age goes up by 1 unit, income goes up by 1 unit. And the unit could be thousands of dollars or $10,000, whatever it is. However, in the real world, in nature, you will never see a correlation of 1 or of -1. That means that you're looking at the correlation of something with each other, with itself. With, how does age correlate with age? Well, it's the same thing. So that's what a correlation of 1 means. A negative correlation, whatever it is, means that as one goes up, the other one goes down. Okay? A correlation of 0 means that they're not related to each other. So as you're seeing, correlation is a measure that goes between 1 and -1. Theoretically, it does include the 1 and the -1. However, in nature, it's very I've never seen it. I've never seen an example of it. So there's three things that when we're looking at a correlation that we want to understand. We want to understand whether, first of all, is there a correlation? Okay? And for that, we're going to be looking at not at these values, but we're going to be looking at something called the p-value to see if the relationship is significant, okay? Statistically significant. That's the first thing. That's not here. Then we're going to look at the sign of it. Is it positive or negative? And lastly, we're going to look at the absolute value, meaning absolute meaning taking out the sign. How big is the value between 0 and 1? And the reason why we're going to do this is that when we describe the correlation, we're going to say, is it significant or not? If it's not significant, you just say, there's no relationship, end of story. If there is a relationship, you're going to say, there is a significant relationship. You will say that the relationship is either positive or negative. And then you'll follow by saying, is the relationship strong, like a 0.8? Is it moderate, like a 0.4? Or is it weak, like a 0.02? Okay? So these are the things that we want to do with correlation. So without further ado, I think examples go a long way. Let's get into R. I'm going to start out by installing some libraries. If you're not familiar with R, I can help you. I can help you one-on-one. You can do this via Zoom. It's perfectly fine. I'm loading these packages just so they're available to use their functions. I'm going to be using today this data called empty cars. And if you're wondering what this is all about, I'm going to run this line over here, okay, which is going to bring up over here a description of the data. The data is basically data on, there's 32 cars and there's 11 variables. There's miles per gallon, how many cylinders, the size of the engine, that's displacement, horsepower, rear axle ratio, no idea what that is, but I guess it's important. The weight of the car, how fast does it do a quarter mile, how many seconds do a quarter mile. VS, is the engine in a V-shaped or is it straight? So 0 means V-shaped, 1 means a straight engine. AM, the transmission, 0 for automatic, 1 for manual. Gears, number of gears, and number of carburetors. So without further ado, let's take a quick peek at the data. So I'm running this function called summary, and I'm saying summary of empty cars. And it gives me a lot of information from the get-go. Just checking on our time here. Okay, so we have miles per gallon that goes from 10 to 34. The average is 20 miles per gallon. We have cylinders, we have 4, goes all the way up to 8. The middle number, the median is 6. Displacement, these are in cubic inches. So if you convert this, then you'll have numbers that perhaps are more familiar to you, like a 2.0 liter engine. Horsepower from 52 to 335. Anyway, and so forth. And by the way, the weight, as it says here, this is weight in thousands of pounds. So weight goes from 1,500 pounds all the way to 5,400 pounds. Okay? Okay, that said, let's do a correlation. So, as far as correlations go, we like plotting things first. So I'm going to run this plot, okay? And again, you don't need to code for this course. And I will describe to you the code that I'm running, but I'd like to take a look at things first. So here I did a plot of miles per gallon by horsepower. You can see miles per gallon and horsepower. If we look at this, for the sake of time, I'm not asking you guys, so I'm telling you. If you look at this, you're going to see that there's kind of like a downward trend. It would seem to be that if there is a correlation, it's probably going to be negative. And we have to ask ourselves, does this make sense? As horsepower goes up, okay, the high horsepower, we have lower miles per gallon. Smaller engine, smaller horsepower, less horsepower engines apparently get more miles to the gallon. Usually that's correct. If you want to visualize what that line going through here would look like, we run this complete code. This last line from this plus sign onwards is going to draw a line for us. So we have the dots are the observations. In the blue would be our correlation, would be our slope here. We don't know if it's significant or not. This is just to visualize what's going on. And if you see what we're doing here, by the way, in R, this data set empty cars is preloaded. So, that's why you're actually seeing it. We didn't load the data, it's just here. Anyway, so let's do a correlation. Okay, our first correlation. This is the code, core.test. Data set empty cars, little dollar sign, hold on, little dollar sign to symbolize that this is the data set, this is the variable. So here we have data set, variable, data set, variable. So let's do the correlation between miles per gallon and horsepower. Run that, and let's see what we get. Just putting this here. So the first thing that's happening, and I know this is a lot of information, keep in mind I'm recording this, is that the first thing that's happening is that I get a p-value. That's the first thing I'm looking for. And a p-value is saying, what is the probability that these results are just random stuff? The probability of this being random is the number 2 times this little e here is saying exponentiating like 10 to the negative 7, okay? So what this means, it's 0.6 zeros and then the number 2. So there's a very, very tiny probability. Ooh, 10 minutes left, I'm not gonna upgrade. Okay, there's a very tiny probability that this is due to random chance. But we need to define a cutoff point. Wherever I see a p-value greater than so much, I'm gonna say there's no relationship. If it's less than a specific value, then I'll say the relationship is significant. So we need to have a cutoff point. And that cutoff point is called alpha. And I'm choosing my cutoff point to be 0.05. So if the probability that the relationship is due to random chance is below 5%, which is my alpha, then I will reject the null hypothesis saying that there is no relationship, and I will say that there is a relationship. So if your p-value is less than your selected alpha, and alpha is a judgment call, okay? Smaller data sets like this one, 0.05 is fine. I will be sending you guys an assignment for you guys to do in your teams, and you will set your own alpha. I will highly recommend that you use an alpha of 0.01. This came out, well, anyway, that's my default. We'll get to how to define the 0.01 alpha, okay? So the first things first, I said 3 things that we're gonna look at. Is it significant? The sign of the correlation and the magnitude. So first things first, it is significant. So I'm saying perfect. The relationship between miles per gallon and horsepower is significant. Done. That's all I need. Next, the correlation is, well, between absolute values, between 0 and 1. I consider this big. It's a judgment call. It's close, pretty close to 1. I would say it's big. So I say the relationship is large. And I'm looking at the sign here, it's negative. it's negative. Here I've covered my 3 bases, okay? Is it significant, sign, and magnitude? That's it. Now, for business decisions, you need to write something that everyone can understand. Because if you write an email saying, hey, the relationship between miles per gallon and horsepower is significant, the correlation is large and negative. I'm still wondering, so what does that mean? Well, that means that in very simplistic terms, you would report that the more horsepower, the less miles per gallon. So I'm asking you a 4th thing that has nothing to do really with stats, but explain it. Explain it to someone that doesn't know what a correlation is, doesn't know what alpha is, doesn't know what a p-value is. You know, in the end, what's the bottom line? What do I need to know? More horsepower, less miles per gallon. Okay, I've got, again, once this video stops in 6 minutes, I will send out another email for continuing here, okay? The next thing is here. So let's just say hypothetically, which in the assignment, I would highly recommend that you set your alpha to 0.01 because the data set is going to have a lot of observations, okay? Is that, again, so let's run our correlation between miles per gallon and displacement. Displacement is the size of the engine. When you want to set your alpha to 0.01, what you're really talking about is confidence levels of 0.99. As you see in our previous example, it gave us results of 95% confidence intervals. That's this gray area in the line. So now we want to be even more confident. So I run this. I'm just going to highlight this and hit run. Okay, so my p-value, again, is very small. Good. So I will say that the relationship is significant. The relationship between miles per gallon and displacement is significant. Because my p-value is lower than my alpha 0.01. This is 9 times 10 to the negative 10. In other words, it's 0.9, 9 zeros, and then the number 9. It's a very small number. I take a look at the magnitude, it's 0.85. That's big. So I say the correlation is strong, and the sign is negative. And negative. Done deal. Okay? In layman terms, what am I saying? The bigger the engine, the less miles per gallon. Done. That's all you have to say. Now, if you're doing correlations and you're really exploring the data, you're going to want to see, you know, you're going to have to go one by one testing the correlations between everything. Here, I'm assuming that the interest is, well, what's related to miles per gallon? There's a way in R, and I'm just going to run the code. I'm not going to explain it. All I have to do is put the data set name here. Anyway, run this, run this. Look what I get. I get this nice big image. And to explain to you guys what this image is about is that this is a correlation matrix. It has all the variables here, all the variables here, and I can tell what the value is, okay, between -1 and 1. I can't tell if it's significant or not. It's not giving me p-values, but it is giving me the strength. Look at this diagonal, which is dark blue. This dark blue corresponds to number 1 because this is the diagonal of a correlation matrix where things are correlated with each other. It's just the way it works. So in other words, the lower part here is symmetrical to this part. So miles per gallon correlates with miles per gallon on a one-to-one basis, and so forth. But we can actually easily identify things, these very small dots and very light colors. There's a possibility that these are not significant. Anyway, I'm going to stop the video here, and I am going to go to I will resend another Zoom meeting. Okay, so check your emails in a second.